All right, so we're going to finish up section A.4, the appendix in the back, looking at multiplying and dividing complex numbers. Okay, so yesterday we said that I is the square root of -1, and I think we already did this too. Anyone remember from yesterday, what is I squared? Yep, -1. Okay, so anytime that we do arithmetic out, I squared should never be in the final answer. Never. Right? Because I squared can always be changed to -1, which means we can then probably combine it with something else. Okay, so don't ever leave I squared in the final answer. Okay, where we're going to see I squared come up is when we start multiplying. Okay? If you remember how to do the double distributive property, or some people call it FOIL, that's very similar to how you multiply complex numbers. Okay, so let's suppose we have two complex numbers, just like we did yesterday, a plus bi and c plus di. Okay, to multiply them together, we basically use the double distributive property, or FOIL. You do a times c, and you do a times di, c times bi, and then bi times di. It's this last one that's going to give us an I squared when you multiply bi times di. Okay, as always, we'll combine our like terms. So your final answer should be a real number, plus or minus, and then an imaginary number. And that's pretty much it as far as the directions on multiplying. Okay, so we'll just try a couple examples. Okay, so we'll multiply 2 plus I times 1 minus I. All right, so Shelby, if I use that pattern of FOIL, what would be the first thing I do? Yep, 2 times 1, which is 2. Okay, Amy, what would be the next thing I would multiply? Nope, the 2 and the I aren't going to get multiplied together. Yep, the negative I, sure. And what would that give me? Negative 2I. Okay, so we did the first, the outer. Okay, Owen, what do we do next? Yep, I times 1, that's the inner. What's I times 1?
I.
Yep, just I, stays the same. And lastly, we finish up with I times negative I. Okay, Yadira, what's a positive times a negative? Okay, so we at least start with that. Positive I times negative I, that's a negative. And then we have I times I. Okay, Tom, what's I times I? I squared. All right, so let's combine what we can for like terms. Brandon, what's negative 2I plus 1I?
Negative I.
Yep, just negative I. Okay, and are we done, Ethan?
Oh, no.
No. What else do we have to do? Yeah, we got to simplify that I squared, and then we're going to be able to combine it with something else. So we have minus, Sarah, what is I squared? Negative 1. Okay, so we have a minus from up above, and then we changed I squared to negative 1. So that's going to become 2 minus I plus 1, okay, because we're subtracting a negative. And now I have one more like term I can combine. 2 plus 1 is 3 minus I. Okay? And that's how you multiply two complex numbers. Any question on what we did there? So there's a little bit of addition and subtraction. You've got to combine like terms. And the first part is really just your double distributive property. Okay, let's try one more multiply, and then we'll move on to divide. Okay, Josh, can you tell me what's the first thing I would multiply?
8 times 3
Yep, 8 times 3.
and 8 times what?
Okay, and can you just tell me what that would be first?
24.
Yep, 24. And then you said 8 times I, which is
8i.
8i. Ben, what do we do next?
You do I times 3.
Yep, I times 3, which is
Oh, 3i.
3i.
And then you do I times I.
Okay.
Leave that square.
Yep, and I times I. It's a positive I squared. Okay, Paige, is there anything I can combine here? Yep, we can combine 8i and 3i, and that gives me 11i. Okay, good. Okay, Adam, what can I do next?
You can turn the I squared into negative 1.
Yes, negative 1. Okay, so make I squared negative 1. Now you can combine it with the 24. We get 23 plus 11i. And that's it.
Question.
Question.
What if, for example, it was like plus 5i squared? What would we do there? Would we just simplify that half of it?
So if you had a plus, if you had that,
Yeah, if that was like part of the answer. Would you further simplify that?
yeah, you could write that as 5 times negative 1.
And then go from there? Okay.
That 5i squared would be
That's
negative
what I
5.
thought.
Yep. Okay, any other questions on that? Okay, multiplying is important because it's how we divide. Okay, it's kind of like when you have two fractions. You divide a fraction by a fraction, you flip the one in the bottom and you multiply. Well, that's kind of how we're going to do division. We're going to end up multiplying, just like this. Okay, but before we can multiply, I have to explain what a conjugate is. Okay, so suppose we have a complex number, okay, which I'm just going to call z. Z is the complex number a plus bi. A and b could be any real numbers you want. This symbol, okay, when you write a z and you put a bar on top of it, that symbol stands for the conjugate of z. Okay, and what is the conjugate? Well, if the original complex number was a plus bi, the conjugate is a minus bi. Okay, so all you have to do to find the conjugate of something is you change the sign. That's what negate means. Change the sign of the imaginary part. Leave the real part alone. You don't change that. So if the imaginary part started out positive, it becomes negative. And then when you do the conjugate, if you had something that started out negative, it would become positive. Okay, so let's just try finding the conjugates of some numbers. Right, let's say I had 3 plus 4i. Okay, what do you think the conjugate of 3 plus 4i would be? Okay, so what do you think the conjugate of 3 plus 4i would be?
3 minus 4i.
3 minus 4i. Yeah, that's it. Okay. How about the conjugate of negative 8 minus 2i? About Sean.
8 plus 2i?
So when you change the sign, just change the sign on the imaginary part.
All right, negative 8 plus 2i.
Yep, good. Negative 8 plus 2i. How about 5i? Negative 5i. And 3. 3 stays the same. You could think of 3 like this. 3 plus no imaginary part, when you negate it, the imaginary part becomes 3 minus 0i. Well, plus 0 minus 0, same thing. Stays 3. Okay, any question on finding a conjugate? Pretty straightforward. Okay, now what I want to do is multiply conjugates together and see what happens. So I'm asking you to multiply a complex number times its conjugate. In this case, the complex number is 3 minus 4i. Okay, we already know the conjugate. It's 3 plus 4i. So let's multiply this out and see what we get. Okay, Max, what would be the first thing I'd multiply?
3 and 3.
3 times 3, and that gives me 9. Iris, what would be the next thing? 3 times 4i, which is how much? 12i. Okay, Lydia, what would be our next product? So what are you multiplying together? So we did the 3 times 3, and we did the 3 times the 4i. So yep, negative 4i times 3, which is how much? Negative 12i. Good. And then the last part, negative 4i times positive 4i. That's a negative 16 I squared. Good. What's going to happen there? Anybody see something right away that, yep?
All the imaginaries and go away.
Okay, yeah, I at least can see these go away. Negative 12i plus 12, positive 12 minus 12. That cancels. And now you have 9, and this is similar to what Andrew asked about. You have minus 16 times I squared. Well, I squared is negative 1. Okay, if we do that out, we've got 9 minus 16 times negative 1 is negative 16. Subtracting a negative becomes addition. And what's my final answer? 25. Okay, so as Sarah just said, when you multiply conjugates together, all the imaginaries disappear. And that's important. We're going to use that trick to help us get rid of imaginaries when we don't want them. Multiply by a conjugate, and that'll do it. Right? So when you have to multiply conjugates, since the imaginaries go away, there's a quick way to do it in your head. Looking at this problem, I already know the answer is 41. Okay, let's see how I did that just by looking at it. Okay, I know I'm going to do 5 times 5 and get 25. When I do 5 times 4i and 5 times negative 4i, those are going to cancel. Okay, so I don't need to bother with that part. And then the last part, that's a negative 16i squared. Well, negative 16i squared. I know that an I squared is a negative, which is going to cancel that negative. So all it ends up being is 25 plus 16. And that's how I got 41 in my head. Okay, so all you really have to do is take the first number, square it, take the second number, just the number, not the I with it, the 4, square it, 25, 16, and add them up. That trick always works for conjugates. If they're not conjugates, it doesn't work. Okay, so here's the shortcut. If you had to do that times that, take A and square it. Take B and square it. Add them up, and that's your answer. Okay, you don't have to use the shortcut, but I will use it because it'll save us a little time when we do division. Okay, and it's only to multiply conjugates. So let's try one example. Okay, so to do this out without foiling, using the trick, what's the first thing I would do? Square the 3. Yep. What else?
Square the 6.
Square the 6. and then add them up. 9 plus 36, the answer is 45. Okay, if you want to FOIL it, go ahead, but you'll see that everything cancels out. Andrew, did you have a question?
No.
No. All right. So now that we know about a conjugate, we can do division. Okay, so if you want to divide two complex numbers, okay, the way you do it is you change it into a multiplication problem. Okay, and what you end up doing is multiplying the top and the bottom by the conjugate of what's in the bottom. So you multiply the top and the bottom of your complex number by the conjugate of what's in the bottom. And what that's going to do is it's going to get rid of all the i's for us in the bottom. Okay, we never want to leave an imaginary number in the denominator. And if you follow this step, that'll never happen. Okay, so our first example with division, we'll do 1 divided by 3 plus 4i. So I'm going to change it to a multiplication. And what will I multiply the top and the bottom by? How about Michaela?
3 minus 4.
3 minus 4i. Yep. Okay, in the bottom, we can do this one quickly. We have a trick for it. Okay, square the 3, square the 4, and add them up. Okay, what's 3 squared? 9. And 4 squared? 16. And what's 9 plus 16? 25. Okay, so the bottom is done. Even the top, that's not really going to be that bad. It's a distributive property. You're just distributing a 1. So 1 times 3, 1 times negative 4i. If that top number was also a complex number, I might have to do FOIL right here. Okay, we'll do one like that in a minute. And then the last part is just to write your answer in standard form. Okay, so to do that, you break the real and imaginary part into 2 separate numbers. The 3 has a denominator of 25. The negative 4 has a denominator of 25. And we put an I on the end. So the real part is 3/25. Imaginary part, negative 4/25. And that's it. Any question on that last step? Just putting each denominator separate. All right, so let's try. We'll try one more with division. I think that'll finish up this half of the section. All right, so we got 1 plus 4i divided by 5 minus 12i. Okay, Zach, what will I do here?
You want to get the conjugate of 5 minus 12i?
Yep. And what is that?
5 plus 12i.
Okay, and what do I do with that conjugate?
You want to multiply that by the top and bottom.
Perfect. Okay, I like to do the bottom first because we have that shortcut. We can do it pretty quick. Okay, Andrew, how would I use that shortcut to do the bottom out?
5 squared plus 12 squared.
5 squared plus 12 squared. And the next step, we'll add them up. Okay, any question on the denominator? Okay, now the numerator, there's no shortcut for that. We gotta go through the whole thing. Okay, so 1 times 5. 1 times 12i. 5 times 4i. Some people do that part in their head. They combine the 12 and the 20. That's fine if you want to do that. Let's do this part out. When you simplify 4i times 12i as much as you can, What do you get? You get what? Well, first you got to do 4 times 12. So start with that. And then think about what I squared would be. About that?
I'm not sure.
Okay, let's do it out. Let's not do it all in our head then. Okay. What do I get when I do 4i times 12i, but don't simplify anything? Yep.
48 I squared.
Okay, we'll start with that. 48 I squared. All right. Let's simplify that denominator. Okay, 169. I'm going to combine the i's. So it's going to give me 5 plus 32i. And now, what's 48i squared? Negative 48. Okay, and to finish up, just write each part with 2 separate denominators of 169. Okay, we have 5 take away 48. What's 5 take away 48? It's negative
43.
Good, negative 43. And then I have 32. That's my imaginary part, and it's positive. Okay, so on the test, that's how you'll see all multiple choice answers. Standard form. Not like what I have up above, but what I circled. Okay, any questions on division? All right. So that finishes up A.4 in the back of the book. Okay, so the last thing we're going to look at is section 5.3. We'll see how much we have time for. Okay, but this is the complex plane. So what the complex plane allows us to do is graph imaginary numbers. And basically the way you graph an imaginary on the complex plane is your real axis becomes the horizontal. Okay, so that used to be x. Well, now that's going to be the real number. So you look at your real number, and you go left if your real number is negative, you go right if it's positive. The vertical axis, that's what used to be y, that's now your imaginary axis. So you look at your imaginary part, you go up if it's positive, down if it's negative. So anybody think they could tell me, starting from the origin, how I graph the point 2 plus 3i?
Over 2 up 3.
Okay, over, which way is over?
Or right 2, I'm sorry.
Yep.
Right 2 up 3.
Right 2 up 3. So really, it's just like graphing the point 2 comma 3. That's it. So that's the point 2 plus 3i. How about 4 minus 8i? Kyle, can you tell me that one? 4 minus 8i?
The right 4 down 8.
Yep, you're going to go right 4 because it's positive, and then down 8 because it's negative. Down 8. How about negative 8? Max, how would you graph negative 8?
To the left 8.
Okay, left 8, and then what?
Just leave it on.
Yeah, that's it. That has no imaginary part, so you're not going up or down. And then lastly, 5i, that would just be up 5. It's like graphing the point 0, comma 5. Okay. Any question on that? That's graphing complex numbers in the complex plane. Okay. All right, so kind of the last big topic we're going to look at is how we write a complex number in polar. Okay, complex number in polar greatly simplifies all of our calculations we have to do with multiplication and division. So all that foiling we had to do, the double distributive property, change I squared to -1, put two separate denominators. You don't have to do any of that in polar. You can look at the problem and do it in your head. All right, so if we have time, we'll try multiplying two complex numbers, but we'll do it in polar instead of all that foiling. And you'll see how much easier that is. Okay, first, we just have to look at, bless you, how we write a complex number in polar. Right, so normally I use A and B. I've switched to using X and Y because now we're talking about graphing. So it makes more sense to use X's and Y's. Okay, that's the rectangular form of a complex number. X is the real, tells you left and right. Y is imaginary, tells you up and down. When you move left and right and up and down, that's a grid. It's like an XY axis. Okay, in polar form, we don't have an X and a Y. Okay, what are the two things that you have in polar? You have an R and you have a theta. So if we look at this point, if you know how to take the point 2, 3 and write that in polar, then writing the point 2 plus 3i, it's almost the same thing. You've got to find that radius, and you've got to find that angle. So it's just like what we did yesterday. Okay, we have formulas for X and Y that change them to R and theta. Does anyone remember what the formula was for X? Yep, so if you don't want X, we can replace it with R cosine theta. And if you don't want the Y, that's R sine theta. Okay, these are the two formulas we learned on Monday. So what I'm going to do is change X to R cosine theta. I'm going to change Y to R sine theta. Okay, and let's see what we get. So we have, instead of X, I've got R cosine theta plus, I still have the I, we're not doing anything with that, but we're going to change the Y to R sine theta. Besides theta, what do both parts have in common? They both have something that's the same. Yeah, they both have an R. Okay, when two things have the same thing in common, you can factor it out. Okay, so that's what we're going to do. If I factor an R out of the first part, that leaves me with just what? Just cosine theta. And if I factor an R out of the second part, more than just sine. Yep, I sine theta. Okay, and that's the polar form of a complex number. It's R cosine theta plus I sine theta. Okay, and then how do we get R and theta? Well, we already have formulas for that too. Theta, well, it depends on the quadrant. You either use inverse tangent of y over x if you're in quadrants 1 or 4, or if you're in quadrants 2 or 3, you've got to add 180 to that. To find R, just use the Pythagorean theorem. Okay, and that's all you have to do. You find R, you find theta, and you just put them in. You don't have to simplify anything. Okay, so here's an example of what a complex number in polar could look like. 2 cosine 15 degrees plus I sine 15. That would be a final answer to a problem. If you do it out, take the cosine of 15 and then double it, take the sine of 15 and then distribute the 2, then you're going to change it back to what you started with. Okay, so we don't do this out. We just stop, we leave it just like that. Okay, we just have to find R and theta. All right, so let's try this one. Okay, square root 3 minus I. All right, so that's rectangular form. The real part is square root 3. What's the imaginary part? It has to be a number, but there's no number in front of I written down.
Is it one?
It's 1. So if you want to think of this as 1i, you can do it that way. Okay, first thing I got to do is I got to know the quadrant. Okay, which quadrant would that be in? Positive, real, negative, imaginary? Yeah?
It would be quadrant 4.
Yeah, quadrant 4. You don't have to know exactly where. Just know the real part is positive, so you go right. Imaginary is negative, so you go down. Right, down. Somewhere in quadrant 4. Okay, when we find our angle, do we need to add 180 to it?
No.
Nope, not in quadrant 4, not in quadrant 1. So it's inverse tangent of y goes on top, x goes on the bottom. So what was the vertical here? What was like our y? The negative 1. Okay, remember, imaginary takes the place of the y. The horizontal, that's just square root of 3. Okay, let's see what we get for an angle. So, inverse tangent of negative 1 divided by square root of 3. Okay, keep your calculator in degrees. We'll get a nice answer. We get negative 30. Which, same trick, if I asked you to write it as a positive, just add, whoops, you could just add 360, and you get 330. Okay, so that's half of it. I got my angle. What else do I need besides the angle? I need the, I need r. So r squared equals, okay, in this case, x squared. That'll come out nice. And y squared. I like to think of it as x and y. Even though it's real and imaginary, it just keeps it the same as what we learned before, so you don't have to think of it differently. Okay, what's the square root of 3 squared? 3. Negative 1 times negative 1, that's 1. So r squared equals 4, so what would r be? 2. Okay, now we can write our final answer. So the final answer is r cosine theta plus I sine theta. R cosine theta plus I sine theta. And that's it. You don't do that out. If you do this out, you're going to change it back to what you started with. Okay? If you took the cosine of 330 and then doubled it, you'd get square root 3. If you take the sine of 330 and then distribute the 2 to that, you'll get negative 1. Okay, so just leave it just like that. Okay, so very, very similar to what we did yesterday. Any question on writing a complex number in polar? All right. So the last thing we'll do is I'll show you how we can take two numbers that are in polar, okay, like this, and multiply them together. Okay, it's easy enough that we should be able to do it by looking at it. It's not going to be any real work to show. Okay, so the polar form of a complex number provides a very fast way to do multiplication and division. Addition and subtraction, you can't really get any faster than what we have. You're just combining like terms. That's already pretty easy. But that division, that one was a pain. You've got to find the conjugate, you've got to multiply it out, you've got to change I squareds to -1. There's a lot of steps. Most people don't find it overly hard to do the FOIL, but it is a lot of steps. Okay, so suppose we had two complex numbers. Okay, I'm going to use r to represent the radius, and I'll use theta to represent the angle. So my first complex number in polar, I called it the first radius, r1, and the first angle, theta 1. Okay, for the number that I'm going to multiply it by, I'm just going to call it my second radius, r2, and my second angle, theta 2. Those will all be numbers in a problem. r1 and r2, theta 1 and theta 2 will all be numbers. Okay, and the product, okay, to multiply those together. Keep in mind what you would have had to do before. You would have had to do the double distributive property, combine like terms, change all your I-squareds to -1, and then combine like terms again. Okay, watch what you do here. To multiply them together, first thing you do is take r1 and r2 and multiply them. And that's it for your radius. Take r1 times r2. Now to get your angle, all you have to do is take the two angles you have and add them. And that's it. So you end up multiplying your two radii together, and you add your two angles together. Okay, there's no foiling, there's no I-squareds, there's no combining like terms, nothing. Okay, so you'll pretty much be able to do this in your head. Okay, so I want to find z times w. Okay, so my first complex number is z. That's the name I gave it, z. It's 3 cosine 20 plus I sine 20. And the second complex number I decided we'll just call w. It's 5 cosine 100, I sine 100. And we're going to do z times w. Okay, start out with your radius. Okay, what's your radius going to be? 15, yep. 15. Cosine, we need our angle. And then we need our angle again. The angle is 120. You're done. That's the whole problem. So to multiply two complex numbers in polar, it's so much easier and faster than doing all that foiling. Okay? But you have to understand what polar means to do this. So 3 times 5 is 15. 20 plus 100 is 120. And you're done. Okay, any question on that? Okay, try another one with multiplication. This time I have 1/2 cosine 15, I sine 15. And 10 cosine -30, I sine -30. Okay, start out with your radius. Okay, what is my radius going to be? 5. Yep, 10 times 1/2. 5 cosine, I need my angle. And then I sine, I need my angle. What's my angle here? Yep, -15. Now, off to the side, let's just... -15, what would that be the same if you did it as a positive? 345. Okay, so instead of writing -15, I'll do it all in one step. Add 360, make it positive. That's not the only way to make the angle positive, but it is the way that I'm showing you how to do it. And that's fine for what we're doing. Okay, 5 cosine 345 plus I sine 345. And you're done. Okay, any question on multiplying? All right. So the last thing is dividing. Well, dividing is just as easy as multiplying. You're just going to switch the operations you're doing. If you're going to divide, what do you think you'd do with R1 and R2 this time? Last time we multiplied them. This time, yeah, we're going to divide them. Yep. Last time we took our angles and we added them together. What do you think we'll do this time? We're just going to subtract them. It's very, very easy. And since you can make a review sheet and use it on the test, you could just write the formulas down so you can remember which one's which. Okay, so to divide two complex numbers in polar, divide the two radii, and then subtract your angles. Okay, just try not to confuse it with multiplying, which is multiply the radii, add the angles. They're both very easy, just don't mix them up. Let's just do one of these. So we have 3 cosine 75, I sine 75. And we're going to divide that by 5 cosine 30, I sine 30. Okay, whether you call your two complex numbers z and w or a and b, you can call, or z1 and z2, you can call them anything you want. The name of it doesn't matter. Just what the actual numbers are. All right, what's my radius going to be here? 3/5. Yep. Just take 3, divide by 5. And what about my angle? 45. Yep, 75 minus 30 is 45. And we're done. Okay, that's the whole problem. So everything that we just did there takes the place of finding a conjugate, doing FOIL, getting rid of your I-squareds, combining like terms, and separating your denominators. We just did all of that in polar. It's much easier. Okay. Any questions on that? All right. Okay, so the homework tonight will be on 560. That part's on multiplying and dividing complex numbers the old way. Okay, and then page 333, writing, let's see, complex numbers in polar. And on page 333, try 11 to 19 odd and 33 and 34. Okay, in 560, that was 15 to 27 odd and 28. Okay, we'll go over that tomorrow before the test, and then we'll have our test on 5.1, A4, and 5.3.